Welcome you all in lecture number 2 of Abstract Algebra MTL 6051. In this lecture, we will going to discuss partition function and problems related on the partition function, Euler's phi function, problem based on Euler's phi function, and construction of dihedral group D4 D3, right? Definition of group and their examples. Like first we will discuss about partition function. What is partition function? A non-empty set capital P is said to be partition of set capital X if and only if a non-empty set capital P is partition of set capital X if it satisfies following condition. Number 1, phi does not belong to P, right? Phi is not element of the partition set P, and union of all partitions in P is equal to capital X. And third, if A is in partition set P and B is in partition set P, then A intersection P is equal to phi, and condition is that A does not equal to B, means A and B are disjoint sets, right? For example, how many partitions of the set ABC, right? First see what are the partition. Partition of 1 is 1, right? How many ways we can write 1? That is 1. What is partition of 2? That is 2. Why? Since 2 is equal to 2, 2 can write it as 2, and 2 can be written as 1 plus 1, right? Therefore, there are two ways to partition 2. Therefore, P2 is equal to 2. What is P3? P3 is equal to, right? 3 can be written as 3. 3 can be written as 2 plus 1, right? And 3 can be written as 1 plus 1 plus 1, right? Now, what is P3? P3 is 3, right? Then, what are the partition set of ABC? Partition set of ABC is written as 1 is 3 element set, right? Partition set of ABC is 1 is 3 element set ABC1, and number 2, 3 can be written as 2 plus 1, then 2 element set and 1 element set. Remember that these sets are disjoint sets, AC and B, right? Are BC and A, right? 2 plus 1 can be written as these three way, 2, 3 and 4. Now 3 can be written as 1 plus 1 plus 1, that is A, B and C, right? Then how many partitions of the set ABC? Number of partitions of the set ABC, number of partitions of the set ABC is equal to 5. 1, 2, 3, 4 and 5, right? Similarly, what are the partitions? Second problem, what are the partition of the set capital X AB? Partition of AB, what is the cardinality of X? 2. Now this 2 can be partitioned as 2, means one set is AB, one partition, and 2 can be written as 1 plus 1, that is A comma B, right? This is partition. Now, how many ways can AB can be partitioned? Two ways, either this or this, right? Therefore, P of 2 is equal to 2. Now, see the general formula. The set containing n plus 1 element. What is that? A set capital X whose cardinality is n plus 1. Set whose cardinality is n plus 1. The number of partition is denoted by P n plus 1, right? This is equal to what is the formula? Summation over r equal to 0 to n NCR PR, right? NCR PR. What is P of 0? Something initial condition like this. P of 0 is equal to 1 and P of 1 is equal to 1, right? Now see what is P2. What is P2? P2 can be written as, first this P2 can be written as into this form, right? Pn plus 1. Then Pn plus 1, 2 is equal to 1 plus 1. Then compare this. What is n? En is equal to 1. What is the formula? Summation r is equal to 0 to n. R equal to 0 to n. What is n? N is equal to 1. Then NCR, 1CR, PR. What is R? R varies from 0 to 1. Then 1C0, 1C0, P0 for R equal to 0. Plus, since this is summation, 1C1, P1. What is that? What is 1C0? 1. What is P0? P0 already given 1. What is 1C1? 1. What is P1? 1. What is that? This is equal to 2. Therefore, P2 is equal to 2. What is P3? P3 can be written as P2 plus 1, right? That is summation r is equal to 0 to n. What is n? N is equal to 2 in this case. Then 2CR, PR, right? Expand this summation. 2C, what is r? R is 0, P0. 2C1, P1. 2C2, P2. What is 2C0? 2C0 is 1. What is P0? 1. What is 2C1? 2. What is P1? 1. What is 2C2? 1. And what is P2? 2. What is the total sum? 5. Therefore, what is the value of P3? P3 is equal to 5, right? Now, find P4? Similarly, P4 can be evaluated as summation over r equal to 0 to 3CR PR, right? Expand this summation. 3C0 P0, 3C1 P1 plus 3C2 P2, 3C3 P3, right? What is 3C0? 1. What is P0? 1. What is 3C1? 3. What is P1? 1. What is 3C2? 3C2 is 3. What is P2? P2 is, what is P2? P2 is 2, right? Plus 3C3 is 1. What is P3? P3 is 5. And this is equal to P3, 1 plus 3 plus 6 plus 5, that is 15. Then P4 is equal to 15. Similarly, what is P5? P5 is equal to 52, right? Similarly, you can evaluate P6, P7 and so on, right? Now, what is Pn means? Pn plus 1 means Pn plus 1. Pn plus 1 means the number of partition of a set capital X containing n plus 1 elements, right? That is, cardinality of X is n plus 1, then the number of partition, this hash is denote the number of partition of capital X, right? And this is the general formula, right? Now, how we evaluate P7, P8, P9, P10, right? See one diagram, very simple method to calculate P10, P11 and so on, right? See the diagram. First, what is P1? P1 is 1. What is P2? P2 is 2. I know that P2 is 2. We already evaluated that. P1 is 1, write 1 here. What is P2? P2 is 1. Then 1 already written, and P2 is 2, write 1 here. 1 plus 1 is equal to 2, write 2 here, right? Now, what is P3? Write this 2 here, this 2 here, 2, right? Then what is P3? P3 is, what is P3? P3 is 5. We already evaluated that, right? Then 2 plus 3, right? 2 plus 3, that is 5. Write 5 here. Now 5 plus 2, 5 plus 2, 7, write 7 here, right? And 7 plus 3, 10, write 10 here, right? Then 10 plus 5, write 15 here. This is P4. Similarly, what is P5? This 15, write this 15 here. Now 15 plus 5, what is that? 20. And 20 plus 7, 27. 27 plus 10, 37. 37 plus 10, 15, 52, right? What is P5? This is 52. Now, what is P6? P6 is equal to, write 52 here, 52, that's 67. 52 plus 15 is 67. 67 plus 20 is 87. 87 plus 27, 114. 114 plus 37 is 151. 151 plus 52 is 203. What is P6? 203. Similarly, we can evaluate P7, P8 and P9, so on. Otherwise, by this diagram or go by the formula, whatever convenient for you. Now, one note, what is the relation between partition and equivalence relation? The number of equivalence relation on a set X, right? What is that? Number of equivalence relation on set capital X is equal to number of partition of set capital X, right? Now come to the prime numbers. What is prime number? See the definition. An integer n is greater than 1. An integer n is greater than 1 is said to be prime if an integer n is greater than 1 is said to be prime. What is the condition? If n has exactly 2 positive divisors, right? For example, 4. How many divisors of 4? That is 1, 2 and 4, right? How many divisors of 5? Number of divisors of 5 is 1 and 5. How many divisors of 6? 1, 2, 3 and 6. How many divisors of 7? 1 and 7, right? See, Those numbers are called prime numbers if their divisor is 1 and number itself. See here, what is the divisor of 5? 1 and 5 means number itself. What is the divisor of 7? 1 and 7 itself. What is the divisor of 6? 1, 2, 3. This is not prime. What is divisor of this? This is not prime. But 5 is prime, 7 is prime, right? Now, what is co-prime? Co-prime number. Two numbers a and b, right? The integer a and b is said to be relatively prime or co-prime if their GCD of two number is 1, right? For example, what is GCD of 4 and 6? GCD of 4 and 6 is 2. What is GCD of 4 and 9? That is 1. If GCD of two number is 1, then these numbers are relatively prime. These numbers are relatively prime number, right? Now, what are the relatively, and one thing note that, right, GCD of two numbers is always a positive number, right? Then what is the relatively prime number to 0? Suppose GCD of A0 is 1, right? If GCD of A0 is 1, then what is A? A is either 1 or minus 1, right? A is 1 or minus 1. Then these two numbers 1 and minus 1 are relatively prime to 0, right? These two numbers are relatively prime to 0. It means how many integers are relatively prime to 0? That is 2. Two integers are relatively prime to 0. How many integers are relatively prime to 1 and minus 1? See, 1 is relatively prime to every integer. For example, GCD of A with 1. What is that? Always 1. No? For all A belongs to Z, right? And GCD of A and minus 1. What is that? 1, right? For all A belongs to Z. It means the number, those who are relatively prime with 1 and minus 1 is all integer Z. All integer A in Z, sorry. Right? All integers A in Z are relatively prime to 1 and minus 1. Right? I already told you GCD is only positive integer. And second note is that GCD of AB, GCD of minus AB, GCD of A minus B, GCD of minus A minus B, all are equal, right? Now, see one problem. What is the problem? If P is prime number and P divides A1, A2, AN, right? What is P? P is prime number. What is that? Prime number. And P divides A1, A2, sorry, multiplication, A1, A2, AN. Now, then this P divides AI means if this P is prime, then this P divides at least one A from here. That is 1 is less than I is less than N, right? Then P divides A1, right? Suppose P divides A1, right? Then this result is already proved. If we assume P divides A1, suppose, then this result is already proved. If not, suppose this is not, then P does not divide A1, then P divides A1, A2, A3, AN, right? Now, if P divides A2, then result is true. If P does not divides A2, then P divides A3 AN, right? Similarly, if P divides AN minus 1, result is true. If not, then P divides AN, right? It means if P divides product of these number A1, A2, AN, then P divides at least one of them, right? Suppose 3. This is 3. 3 divides 5 into 6 into 4 into 2, right? 3 divide this number. What is this number? 5 into 6, 30 multiplied by 8, 240. 3 divides 240, right? That is 3 divides 240 is equal to 5 into 6 into 4 into 2. Then this 3 divides either 5 or 6 or 4 or 2. 3 divides 5? No. 3 divides 6? True. Right? Then this problem says this. If P divides this, then P divides AI at least one I. Now for one I, P divides AI. Right? This is the proof. Right? If P divides any prime Pi, then P is either 1 or minus 1 or Pi or minus Pi. Right? What is twin prime? Twin prime are those primes. See, two numbers P and P prime is said to be twin prime. Is said to be twin prime if P dash minus P is equal to 2. Right? Then 3, 5 is 2. 11, 13 is 2. Right? Next we will study one operation. That operation is known as, see, what are the fundamental operation? Addition, subtraction, multiplication, division. These are the fundamental mathematical operations, right? Besides these fundamental operations, there are many operations, right? One operation we are going to discuss. What is that operation? Congruent modulo. Congruent modulo. What is that? This congruent modulo is denoted by the symbol 3 line, and here is some number A and some number B, and this can be read as A congruent to B, A congruent to B modulo N, right? This thing, A congruent to B modulo N. Then A congruent to B modulo N. What is the meaning of that? Meaning is that if B divide A by small n, then remainder is B. Remainder is B. Either this or n divides A minus B. Or you can say this. Now it means if we divide A by n, then we got remainder B, or n divides A minus B. Right? This is the definition of congruent. Right? For example, 6 congruent to 2 modulo 4. It is true or false? It is true. Why? If we divide 6 by 4, then our remainder is 2. Right? This is 2. Or 4 divides 6 minus 2. It is also true. Right? Euler's phi function. What is Euler's phi function? A mapping phi from capital N to N. A mapping phi from capital N to N defined as, what is phi of n? Phi of n is those natural numbers in capital N such that 1 is less than x is less than n, and GCD of xn is 1. What is phi n? All those numbers, natural numbers, which is greater than or equal to 1 and less than or equal to n, and their GCD with n is 1. Right? See, what is phi 1? Phi 1 is equal to all those natural numbers in capital N such that 1 is less than x is less than 1 and GCD of x is equal to 1. What is that? This is 1. Phi 1 is equal to 1. And modulus of this is 1. And what is phi of 2? Right? All those natural numbers which are relatively co-prime with 2, that is 1. Only 1 and 2. GCD of 1 and 2 is 1 and nothing else. What is phi 3? How many numbers? 1. 1 is co-prime with 3 and 2 is co-prime with 3. That is 2. What is phi of 4? 1, 3, right? This is equal to 2. What is phi of 5? How many numbers relatively prime to 5? 1, 2, 3, 4. Right? These numbers are less than this. Less than 1 is greater, 1 is less than or equal to s, is less than or equal to 5, and their GCD of 1 5 is 1, GCD of 2 5 is 1, GCD of 3 5 is 1, GCD of 4 5 is 1. Right? This function is Euler's phi function. We use this function frequently in the group theory. Right? Now, what is phi of Pn? Suppose we have to evaluate phi of 8. What is phi of 8? Phi of 2 to the power 3. What is phi of 2 to the power 3? That is 2 to the power 3 minus 2 to the power 3 minus 1. That is 8 minus 4. That is 4. Right? Then phi of 8 is equal to 4. It means there are 4 natural numbers which is greater than 1 and less than 8 which are relatively co-prime with 8. See, what is those numbers? 1 is relatively prime with 8, 2 is not, 3 is relatively prime with 8, 4 is not, 5 is relatively prime with 8, 6 is not, 7 is relatively prime with 8. Right? Then what is the total number? 4. Then phi of 8 is equal to 4. What is phi of 6? Phi of 6 is equal to phi of 2, phi of 3. Means what is 6? 6 is 2 into 3. Right? See the formula. Phi of m into n is equal to phi m and phi m. Right? If m and n, GCD of m and n is equal to 1. Right? See, phi 2. What is phi 2? Phi 2 is equal to, right? Phi 2 is equal to 2 minus 1. And phi 3 is equal to 3 minus 1. 2 minus 1, 1 into 2 is equal to 2. Now, phi of 100 is equal to phi of 25 into 4. Phi of 25, phi of 4. Phi of 5 square, phi of 2 square. What is phi of 5 square? Phi of 5 square is equal to, see here. What is 5? 5 is p. Apply this formula. P to the power n. What is n? N is 2. 5 की power 2 minus 5 की power n minus 1 that is 2 minus 1 into 5 of 2 square that is 2 की power 2 minus 2 की power 2 minus 1 that is 5 square 25 minus 5 multiplied by 2 square 4 minus 2 that is 20 into 2 what is that 40 means 40 numbers which is greater than 1 and less than 100 are relatively co-prime with the 100. What is phi n? Phi n is always even number. What is phi n? Is always even number. How we will prove this? We will prove it as follows. See, suppose two cases. Number one, n is greater than 2, then n can be written as this. If n can be written as this, then what is phi of n? Phi of n is equal to phi of 2 to the power k. We already know that phi of p to the power k is equal to 2 to the power k minus 2 to the power k minus 1. And solve it. 2 to the power k minus 1 that is 2 minus 1. This is equal to 2 to the power k minus 1 and this is even number. Means first case is true. If n is equal to this form, then this is true. If n does not equal to 2 to the power k, then n is equal to p to the power k into any other integer, right? Suppose one example that n is equal to 75. What is this? This is equal to 25 into 3. And what is this? This is equal to 5 की power 2 into 3. Means p to the power k, p means prime number, 5 is prime number, p to the power 2 into 3. Now, what is phi of n? Phi of p to the power k into phi of n. What is phi of p to the power k? P to the power k minus p to the power k minus 1 into phi of n. What is this? P to the power k minus 1 p minus 1 and phi of n. What is this number? This number is even number, and if we multiply any number by even number, then number is even. Therefore, this number is even number, right? What is Euler's phi function? Euler's phi function is not onto function. Why? Phi of n is equal to 3. Is there any such n exist? No. Why? We already proved this result. Phi of n is always even number for n is greater than 2. Right? This is equal to 3. This is not even number. Therefore, Euler's phi function is not onto function. Right? Phi is not invertible since the function is invertible which is 1 1 onto. Right? This is not onto, this is not 1 1. Why not 1 1? Since phi of 1, what is phi of 1? Phi of 1 is 1. What is phi of 2? Phi of 2 is 1. Right? Then 1 and 2 are two elements in the domain which image is same. Therefore, this is not 1 1. Euler's phi function is neither 1 1 nor onto, and therefore it is not invertible. Phi n is equal to 13. Find n. Not possible. Why not possible? Since this is odd number. Right? Now, see the definition of group. Come to the group theory. Let us consider a non-empty set G. Right? What is that? Let us consider a non-empty set G and an operation this. Right? We are not saying this, it is binary operation. This is any operation. Then non-empty set G with the operation is known as algebraic structure. This is known as algebraic structure. Right? This is algebraic structure. This algebraic structure is group if it satisfies following condition. Number 1, for all AB belong to G such that A of B belong to G, means for any two element in G, if we apply operation between these two elements, then new element generated by this operation is also in G, right? This is closure law. Now associative law. What is associative law? For any ABC, A operation B of C is equal to A operation B of C, right? Now existence of identity. What is that? There exists an element E belong to G such that A of E is equal to E of A equal to A for all A belong to G. And what is existence of inverse? For all A belong to G, there exists A inverse belong to G such that A of A inverse of A is equal to E. Now see, let us consider set of natural number with respect to addition, right? Consider any two numbers 2 and 3. What is 2 plus 3? 5. 5 is again belongs to natural number. What is 5 plus 8? That is 13. Again natural number. Means sum of two natural number is always natural number. Therefore, this is closed. This is closed. Associative law is satisfied. Either A plus B plus C or A plus B plus C for all ABC in the natural number, right? But if A belongs to N, then what is A plus A? A plus what is this number? This is equal to A. What is this number? No such number exists in the natural number such that their sum is A. Therefore, existence of identity is not happen. If existence of identity is not happen, we will not go to inverse, right? Since inverse operation will give us identity. Identity does not exist. Then this N plus satisfy two property. One is closure law and another one is associative law. This is known as semigroup, right? If any algebraic structure satisfies these two laws, that is closure law and associative law, this type of structure is known as semigroup, right? If any algebraic structure satisfies closure law, associative law, and existence of identity, then this is known as monoid, right? We will discuss in detail later on. Now, what is abelian group or commutative group? A group is said to be abelian. A group this is said to be abelian if it satisfies A of B is equal to B of A for all AB, right? Z plus H group. Yes, Z plus H group. Why? What is set of integer? Set of integer is 0 plus minus 1 plus minus 2 plus minus 3 that's one. Now, what is sum of two integer? Sum of two integer is always an integer. Whether the associative law is satisfied? Yes, associative law is satisfied. What is identity with respect to addition? 0 is the identity with respect to addition. What is the inverse? Inverse of 1 is minus 1, 2 is minus 2, 3 is minus 3, right? That's 1. Therefore, this is group. In fact, Z plus is abelian group. Why? For any two integer A plus B is equal to B plus A. The sum of two integers satisfy commutative law. R dot is group. R dot is group. No. Why? What is the inverse of 0? 0 inverse does not exist. Therefore, this is not group. What is Z minus? Z minus is group. No. Z minus is not group. Why not group? Since it not satisfy associative law. What is that? Suppose 1, 2, 3. 1 minus 2 minus 3 is equal to, by associative law, this can be written as 1 minus 2 minus 3. What is this? 1 minus, what is 2 minus 3? Minus 1. What is that? 2. That is LHS equal to 2. What is right hand side? Minus 1. Minus 3. What is this? Minus 4. This is minus 4 and this is 2. They both are equal? No, not equal. Right? Therefore, Z minus is not group. Z dot, Q dot, R dot. What is dot? Dot is usual multiplication. Usual multiplication, the multiplication we know. This dot is usual multiplication. This is usual multiplication. Right? Then Z with respect to usual multiplication, Q with respect to usual multiplication, R with respect to usual multiplication, complex number with respect to usual multiplication are not group. Right? Then what is Z star? Consider Z star is this set 1 and minus 1. This is group with respect to multiplication. Right? Later on we will discuss by the composition table of this example. Now Q star. What is Q star? Remember that Q star always denote the set excluding 0. What is R star? That is R minus 0. What is C star? That is C minus 0. Right? Now, what is U8? U8 is this. What is U8? U8 basically means all the numbers who are the relatively co-prime with 8. We already discussed in previous slide. What is the GCD of 1 and 8? That is 1. What is GCD of 2 and 8? That is 2. Therefore 2 does not belong to U8. GCD of 3 and 8? That is 1. 3 belong to U8. GCD of 4 and 8? This is 4. 4 does not belong to. GCD of 5 and 8? This is equal to 1. And 5 belong to U8. Similarly 7. Then 4 elements are co-prime with 8. 1, 3, 5 and 7. Right? See the dihedral. What is dihedral? Dihedral is denoted by Dn. Right? Always dihedral is denoted by Dn and defined as xi, this xi yj. What is Ex satisfies this equation. X2 is equal to E and Y satisfies Yn is equal to E and Xy is equal to Y inverse X. Right? This I varies from 0 to 1 and J varies from 0 to n minus 1. Right? This structure is known as dihedral. Right? Now see what are the notations. Xy is generator. Xy is generator. This X is reflection. Y is rotation. This relation is known as relator and this relation is known as relation. Right? Now the number of reflection and number of rotations are equal. Number of reflections and number of rotations are equal. Right? The number of reflection and number of rotations now is equal to 2n. Then order of dn is equal to 2n. Let us consider how we constructed d4. What is d4? What is dn? We already discussed. Xi yj. X square is e. What is n? N is equal to 4. Y4 is equal to e. Xy y inverse x. Right? Now 360 is divided by n. 360 degrees divided by n. What is n? N is equal to 4. Then y is equal to 360 divided by 4. Y is 90. Right? Then y y square, y3 and y4. y4 again gives that identity, right? If we denote y as 90, that is R90, R180, R3. Now what is E? That is R0, right? This is rotation. See, suppose we have one rectangle and all four corners are marked by A, B, C, D. This corner is A, this is B, this is C, this is D. Now don't rotate this, then there is no change. These two rectangles are same. Now the same rectangle can be rotated by 90 degree. If we rotate it 90 degree, then B came here, C came here, D came here and A came here, right? This one. Again, if the same rectangle rotated by 180 degree, this is 90 degree, again rotate this, then A will come here, here, B here, B will come here, A will come here, B here, C here and D here, right? Then this is R180. Again rotate this one 90 degree, we got 270. D here, A and B and C and D, right? These operations are rotations. Rotations R0, R90, R180, R270, right? Similarly, what are the reflections? Horizontal reflections, vertical reflection and reflections along both diagonals. This is the rectangle, marked corner with ABCD. Now horizontal rotation, AB, A here, B here, C here, D here, right? This one. Vertical, this is vertical. Diagonal, diagonal. This is right opposite diagonal, this one, right? Then construct D4 is equal to R0, R90, R180, R270, H, V, D and D dash, right? Total 8 elements. These 8 elements forms group, right? With respect to composition, forms group with respect to compositions of operations. See, R90 and H. This is rectangle. Now operation is applied from the right hand side. First you apply H. H means horizontal, right? CB goes to down and DA goes to upside, right? Then apply horizontal operation, you got this. Again R90, you got this. This D dash. What is this? This is D dash. You can verify it. R90 applied on this rectangle R90, you got this. And horizontal, you got this. This is D. Now see, if A of B is equal to B of A for all AB belongs to G, then G is commutative. G is group. If it satisfies this operation, then this is commutative. Dihedral is not commutative. Why? Since we already checked in this example, R90H does not equal to HR90. Since this is D dash and this is D, they both are not equal. See the composition table. This composition table we will discuss in later on. Similarly, we can construct a dihedral group of order 3, right? D3 of order 6, sorry. Dihedral group of order 6. Now see, this is one triangle R0. R0 is same, right? No change. are 20, rotate it 120 degree. Then A will comes here, B here, and C here, right? This form. Again, rotate this in 270, right? Not 270, this is 240, sorry. This is 240. Again, rotate it in 240 degree, right? This one again rotated through 120 degree. Then C came here, A goes here, B goes here. This is R240. Now, f of AA. What is f of AA? Reflection operation. A is fixed, B and C can be interchanged. This one. F of BB, B is fixed, C and A interchange. What is this? C is fixed, A and B interchange. Right? Now, what is D3? R0, R120, R240. F of capital A small a, F of capital B small b, F of capital C small c. Right? This is also forms group with respect to composition operation. Composition operation. Right? Okay, we will stop here. In next class, we will discuss in detail about the dihedral group and other related problems of the group. Okay, thank you.